Good morning friends. Today we will discuss about the stress strain curve for the mild steel. In the figure you can see on the x-axis it is strain and the y-axis it is stress. When we apply the load on the specimen of the mild steel, the variation of the strain will be linear up to A, and this A point is known as the limit of proportionality. What is the meaning of limit of proportionality? When we apply the load of any magnitude to the specimen, and when an elongation will be there, and when we will remove that load, the specimen or material will get its original shape. For an example, if there is a specimen of mild steel, say length of 3 centimeter, and when we apply the load it becomes 3.2 or 3.5 centimeter, and when we remove the application of the load, the specimen again gets its original shape of 3 centimeter. It means जब हम लोड हटाएंगे तो वो अपने ओरिजिनल शेप पर आ जाएगा, and this point is known as the proportionality limit. On further increase of the load, the curve follow the path of A dash, which is slight curvature, and A dash is the point which is called the elastic limit point. What is the meaning of the elastic limit? When again the same concept as the limit of proportionality, when we remove the load, it will regain its original shape. Then what is the difference between the proportionality limit and the elastic limit? In the proportionality limit, the variation of the strain is linearly up to A, while in the elastic limit, the variation of the strain is non-linear. On further increasing the load, the curve follow the point B. The point B is known as the elastic limit. Then corresponding to this point, the point B is known as the yield point, and corresponding to this point, the stress is called the yield stress. Now, what the yield point is, or what is yielding? When the shape of the material or the specimen deform or comes in deformation mode, then that point from where the deformation is start, it is known as the yield point. On the same stress or the constant stress, that is yield stress, further increase the stress strain is continuously increasing up to point C. मतलब yield stress जो है मेरी constant stress है, और यहाँ से point B से C तक जो है मेरी strain फिर भी बढ़ रही है constant stress पर, और ये range जो होती है ये plastic range कहलाती है. The material enter in the deformation mode or the plastic stage from the elastic stage. मतलब up to B it is somewhat elastic stage, but after B it is plastic stage. Now further increase of the load beyond C, the stress is increasing up to D, and corresponding to D it is called the stress is known as the ultimate stress, and this part from this range from C to D is called the strain hardening. What does it mean? मतलब अभी मटेरियल जो है वो उसने अपनी अल्टीमेट स्ट्रेंथ C तक अल्टीमेट स्ट्रेंथ नहीं ली है, और फर्दर इंक्रीज ऑफ द लोड इट इज गेनिंग इट्स स्ट्रेंथ, मींस इट इज द मटेरियल गेटिंग हार्डन्ड, एंड एट पॉइंट D इट इज द अल्टीमेट स्ट्रेंथ. मतलब मटेरियल अपनी मैक्सिमम अल्टीमेट स्ट्रेंथ तक पहुंचा है. नाउ द फर्दर increase in the load, the curve follow D path D to E. D is the point beyond D, E is the point beyond D where the fracture comes. Now, what is the meaning of fracture here? On the application of the tension load, when the first crack come in the specimen, that point is known as the fracture point. and D to E, this range is known as the necking. अब ये necking क्या है? If suppose there is a cylindrical specimen of diameter D, on application of the tension load, when the elongation comes, the diameter D start decreases. Say by D dash, where D dash is the diameter which is less than the D. Now this इसका नैरो होना, डायमीटर का नैरो होना इज नेकिंग. ये नेकिंग कहलाता है. On next slide, as I explained earlier, the point A is the proportionality limit. A point is the proportionality limit. The variation of the strain here is linearly. The stress is proportional to strain, and the stress-strain relationship will be linear. Point A dash, as shown in figure, A dash is the elastic limit. Here the stress-strain relationship will be non-linear. Further, the point B, that is the yield point. From yield point, the plastic deformation of the material starts as up to C, as I have explained from the diagram. In the diagram, from B to C, it is the plastic limit, and point B is the yield point, and corresponding to this point B, the stress is called yield stress. On further increase of the load, the curve follow the path of CDE. As I explained earlier, the D is the point where the ultimate stress comes, that is sigma U, and this range is known as the strain hardening range. And further increase of the load, the graph falls up to point E, where the first crack comes, and this point is known as the fracture point, and this range is known as necking. So friends, this was the relation between stress-strain curve, relation between stress and strain for the mild steel curve. This test is performed on universal testing machine, and this is the behavior of the different load condition on the specimen. Thank you.